I'll explain you how to use Industrial Automation Laboratory, which is developed under the National Mission on Education through ICT by College of Engineering Pune. Go to the website of College of Engineering Pune. This is one way to go for it, and click on to the virtual labs. This will lead you to the main website of virtual labs called as vlab.co.in, under which you will find all the participating institutions labs, and either you can click on to College of Engineering Pune or you can click on to electrical engineering, because Industrial Automation Laboratory is under electrical engineering. So let me go to College of Engineering Pune labs, and from where I'll click on to Industrial Automation Lab. Now once you click on to that, there will be a list of experiments which are available. Now these are the experiments which are being developed under the Industrial Automation Laboratory. Study hardware and software platforms for distributed control system. Simulate analog and digital function blocks. Study and understand and then perform experiments on timers and counters. Logic implementation of traffic control application. Logic implementation for bottle filling application. Tune a PID controller for heat exchanger using distributed control system. Function block diagram for autoclavable laboratory fermenter. And the last, develop graphical user interface for the fermenter plant. Let me first explain you how to use this entire platform by taking one experiment wherein all the instructions are available. These instructions are under a BD for autoclavable laboratory fermenter. We expect that you will study aim, pre-test, theory, procedure, post-test and all those things, and then you will start using the simulator. Click here for simulator. The compiler developed for distributed control system laboratory under the heading of industrial automation is being shown here. You will find there are IO instructions like analog input, analog output, digital input, digital output. Under control, there is a PID controller. Under math operation, we have 4 instructions called as add, subtract, multiply and divide. Under timers, we have on delay timer, off delay timer, retentive timer, and to reset the retentive timer, there is a reset instruction. Under logic operators, we have AND, OR and NOT logic, and under the counter instruction, we have up counter, down counter, and to reset these counters, there is a special instruction called as reset instruction. Now let me demonstrate you how to use this tool. First, you can drag and drop the instructions from the instruction pan to the workspace. This is called as workspace. So what I will do is I'll add one digital input and I'll add one digital output. Now what I want to do is I want to test how AND logic can be implemented using this platform. So let me put these 2 digital inputs, because it's 2 input and 1 output AND logic which I want to implement. I'll go to logical operator and put the AND instruction and place this instruction in the workspace. Once I do this, now this is important that you drag this, the lead will come and connect it. Now this indication should be there, and when you release this, you will find that this lead is getting connected to the input. Once you have consumed that input, other input will get automatically added. So if you want to add one more input, go here, don't click here. If you click here, he will say no, the connection will not be done because this is not a proper connection. So what you have to do is go to this and release the mouse once you reach to the other. Naturally, the third input will be added. As we are not using third input, this will remain as it is. So let me connect this to the output, to the DO card. So the same way I have connected the output. Now what you will be doing is, now you will be compiling the program. Click on to compile. Once you compile, the run tab will be on, and click on to run tab, indicating that now this circuit is now in the running mode. Hence you can test the logic. So go to digital input, right click and toggle. Now the value will become 1, so the output of this DI will become 1, which will get connected to the AND gate. But the truth table says if this is 1 and this is 0, look at the DI, other DI, which says value 0. So this is 1 and 0, output will be 0. So 0 will be sent to DO, so DO will remain 0. Now if you go and click on to second digital input, you will find this has become 1. So this is on, so the output has become 1. Output of AND gate is connected to DO, so this DO has become 1. Similarly, you can develop the logic for OR gate, NAND gate, NOR gate using these 3 blocks, AND, OR and NOT. Now this is the space which is available to you. If you are facing any difficulty as far as space is concerned, you are required to click this, so that this block will be minimized like this, this block will be minimized like this, drag and drop that box and release it over here. Similarly, this can be done for DO also, so you can do this. You can keep this AND over here. So this now space is available for you to add more logic. Now while doing it, if you are online, as compile and run, both the buttons are gray, it indicates that now the logic is running. You have to stop that logic. So once you stop, then again compile will become blue, indicating that you can add one more logic here. So let me add, for a demonstration, a logic of OR. So what I will do is, I'll take again 2 DI blocks and I'll place them here. So what I have to do is click here, drag it and place it over here. Once I do this, then again I'll go to OR and I put OR over here, and then I have to connect that to DO. Now without connecting it to DO also, I can test it directly from the OR. This value will become 1 or 0. So now what I will do is, I'll connect here. So connect this, go here and connect to second, then connect OR gate to the DO. And once you have done this, compile this program and now run the program. You will find now this is 0, this is 0. Now if I make this 1, like toggle this, this will become 1. Because this is OR gate, output will become 1. Naturally your DO will become 1. But if I make it 1, again it will remain as 1, because 1, 1 is 1. But if I make it 0, if I toggle this, this has become 0. But this continue to remain 1, your output is 1. This is how you can test the OR logic using functional block diagram. It's called as FBD. Now if you want to see, as it is being shown here as a DI as none. The meaning of the word none means there is no sufficient space. So if I click here, I will find value 0. So you can click again and reduce the size, and again make the space available for your logic to work. Now this is the space available to you. This is called as area 0. Now if you don't want to use area 0, you want to stop the operation, you don't want to execute the logic which is related to this particular area, you go and you can right click area 0 and you can disable area 0, provided this entire circuit should not be running. So I'll stop it, and now if I click here area 0, you will say disable tab. The moment I disable tab, then this entire logic will not be executed. If I want to start again, click to area 0, enable tab, this circuit is available to you. This is how you have to use this platform called as distributed control system, development of logic using function block diagram.